Hi everyone, welcome to the class. So, so this is the first class on a series of classes that I'm going to take on Laplace Transform. So these series of lectures will be focusing on Laplace Transform problems. So whatever questions are there in the last 15 years on Laplace Transform, GATE previous year questions, so I'll be solving each and every one of them. So while solving each and every one of them, I'll be revising the little bit of concept regarding that question. Okay, so you can follow the classes. Each class will be of half an hour. So the first part will be of half an hour. Similarly, other parts also will be of each of half an hour. Right. So let us start with the lecture. So let me take some previous year questions. In this first lecture, I'll be focusing on basic Laplace transform and its properties based problems. In the next lecture, we'll be focusing on some other model of problems. Right. Look at the first problem. So let me revise the basics required for it, and then we'll do the problem. So they're asking us to find the Laplace transform of shifted version of f of t. So which means here we have to use a time shifting property. Okay. So let us use the property. I'm just recollecting the property once. So x of t. Let's say if x of t has a Fourier transform of x of s, has a Laplace transform of x of s. If x of t has a Laplace transform of x of s, then x of t minus t naught, time shifted version of x of t, has a Laplace transform of e power minus s t naught into x of s. T naught is the shifting. So if there is a minus sign in time domain, in time shifting, if there is a minus sign here, there is a minus sign here. So sign will be same in time shifting property. So similarly, x of t plus t naught, if you are understanding the property of x of t plus t naught, which is same as this property. So if it is a plus sign here, it will be plus sign here also. If it is e power plus s t naught into capital X of s. Okay, so let us apply this property here. So they're asking us, that's telling us that f of t has a Laplace transform of capital F of s. F of t minus capital T has a Laplace transform of, according to this property, in place of t naught, we are having capital T. So it will be e power minus s into, the delay is t units, into same Laplace transform. Because of shifting, Laplace transform will be a little bit modified with this term e power minus st. Yes, the answer will be e power minus st into capital F of s. Right. So that is the answer for the first question, which is based on time shifting property. Very simple property. Next one. Let us do the next question. First, let me give you the basics. The basics required for this question is exactly same as time shifting property. So let us plot the signal for understanding it better. So if you plot the signal, they're saying it is 1 for time from A to B, it seems. Starting from time A to time B, the equation of the signal is 1 unit. So this is how it looks like if you plot it. F of t looks like this. Now tell me, how can we write the equation of this signal? If you can write the equation of the signal, always the technique is simple. Whatever signal they give you, I try to express the signal in terms of the signals for which you know the Laplace transform already. Okay. So let us write this signal in terms of known signals. How can we express this? We can express this in terms of step signals, because we know the Laplace transform of step signals. If you can express this in terms of step signals, then finding Laplace transform will be very easy. So f of t can be expressed as u of t minus a minus u of t minus b. Subtraction of step signals always results in a rectangle. Yes, this is what is f of t. Now tell me, u of t Laplace transform we know already, which is 1 by s. ROC is real part of s greater than 0. Now u of t minus a, u of t minus a Laplace transform is, according to time shifting property, it is e power minus as into 1 by s. What happens to the ROC? ROC is the real part of s greater than 0, And if you look at this one, because of e power minus s, will the ROC change? Will the ROC change? It might change a little bit, because if you put, if let us say a is positive, and if a is positive, if s is minus infinity, then for s equal to minus infinity, it becomes infinity, right? If a is positive and s is minus infinity, e power plus infinity will become infinity, which means s equal to minus infinity will become the pole. So s equal to minus infinity should not be part of the ROC, right? S equal to minus infinity already is not part of the ROC. We don't need to remove it from the ROC. Now, if A is negative, we don't know whether A is positive or negative, right? If A is negative, for example, if A is negative and negative into negative is positive, if s equal to infinity, then this becomes infinity. So for whatever value of s, the Laplace transform becomes infinity. We can call it as pole. So for s equal to infinity, this becomes infinity. So s equal to infinity can be treated as pole if A is negative, and we don't know whether A is negative or not. So this is the ROC if A is positive, but if A is negative, then the ROC will change a little bit. You can say it is 0 less than a real part of s less than infinity if A is negative, and this is the ROC if A is positive. ROC will change a little bit. We are excluding infinity. I hope you are understanding why we are excluding infinity from the ROC. ROC should never include. ROC means what? The region of the values of real part of s for which Laplace transform converges or takes finite values. So if A is negative, negative into negative is positive. If s is infinity, if you put s equal to infinity, this becomes infinite. Laplace transform becomes infinity. Laplace transform is not converging for s equal to infinity. That's why we are removing s equal to infinity from the ROC. Whereas if A is positive, then for s equal to minus infinity, we are getting infinity. So s equal to minus infinity is not part of the ROC, but already s equal to minus infinity is not part of the ROC. We don't need to remove it. Right? Like this, there is a very small change in the ROC. If you neglect it also, that is fine, but this is the correct way of understanding the ROC. Right? Let us write the ROC for u of t minus b also. U of t minus b ROC is e power minus bs into 1 by s. ROC is, simply speaking, it is real part of s greater than 0 for b greater than 0. If b is positive, yes, the ROC is exactly same. But if b is negative, then the ROC will change a little bit, and it becomes real part 0 less than real part of s less than infinity. Right. Now let us find the ROC for final Laplace transform of the total signal that is given. So f of t is equal to u of t minus a minus u of t minus b. The Laplace transform is u of t minus c. Laplace transform we know it is e power minus as into 1 by s minus u of t minus b. Laplace transform is e power minus bs into 1 by s. Here we are using linearity property here. If you know the Laplace transform of two signals, and if those two signals are added or subtracted, corresponding Laplace transforms also will be added or subtracted. So what is ROC finally? Intersection of ROCs, real part of s greater than 0, real part of s greater than 0. Intersection will become real part of s greater than 0, or the ROC can be 0 less than real part of s less than infinity. The ROCs can be one of them based on A and B being positive or negative. Okay, it can be any of them. Right. So that is the answer. So finally, the answer we can simplify it and write it as is e power minus as minus e power minus bs divided by small s. That is the answer. It's a simple question. Fine. Okay. One second. So here I'll just revise. Here I've told you time shifting property, but I did not talk about ROC here. Let me talk about ROC. Here let me say ROC is R1. ROC of x of t, Laplace transform is x of s. ROC here is R1. R1 means it can be real part of s greater than 0, greater than 2, anything like that. I'm just calling it as R1. R1 consists of the collection of values of a real part of s for which the Laplace transform converges. Right, now tell me this. So because of time shifting, is there any change in the ROC? There might be. So if you observe, if t naught is positive, let us assume t naught is positive. Then if you put t s equal to minus infinity, then minus of minus infinity becomes plus infinity, e power plus infinity becomes infinity. So because of time shifting, at s equal to plus infinity, so at s equal to minus infinity, the Laplace transform is becoming infinity. If for a particular value of s, the Laplace transform is becoming infinity, that particular value should not be part of the ROC. So we have to remove ROC is exactly same ROC, but remove that minus infinity from the list, because minus s equal to minus infinity is becoming the pole here in this ROC. S equal to minus infinity is becoming a pole, and so s equal to minus infinity should be excluded from the list of ROC values. Similarly, in the next case, it is plus st naught, assuming t naught is positive. Assuming t naught is positive, if you put s equal to plus infinity, this becomes infinity. For s equal to plus infinity, this becomes infinity, which means s equal to infinity is a pole. We can say that s equal to infinity is a pole of this Laplace transform. So poles should not be included in the ROC. So let us remove that pole, which is infinity. Okay, this is how we can write it. The same basic we are applying in this problem also. Fine. So let us look at the next question. So let me write the properties that are involved in this problem. If x of t has a Laplace transform of capital X of s, ROC is R1. Now, if x of t is multiplied with t, so we call this as multiplication with t property. If in time domain the signal is multiplied with t, we can see the Laplace transform. It is minus d by ds of x of s. Will the ROC change? The ROC will not change because of multiplication with t property. Right. So using this property, let us find the result for this question. So u of t Laplace transform we know. Is 1 by s. Now if you multiply with t, Laplace transform will be minus of d by ds of minus d by ds of x of s. If signal is multiplied with t in time domain, in frequency domain differentiation is happening and then minus sign will be there. So d by ds of 1 by s. This signal is multiplied with t in time domain, the corresponding Laplace transform will be differentiated and a minus sign is applied. So the ROC for u of t I did not write, so it is real part of s greater than 0. And because of multiplication with t property, ROC will not change. Real part of s greater than 0. So if you differentiate this, this becomes minus 1 by s square, minus and minus cancelled, it becomes plus 1 by s square. And this signal is nothing but r of t. And Laplace transform r of t should be familiar for all of you. But anyway, I'm just revising this property, if at all if you are not aware of this property. So r of t Laplace transform is 1 by s square. Similarly, let me give you some general result here regarding this property. So t to the power of n into u of t. So if you multiply t n times, then what happens to the Laplace transform? N times differentiation happens with respect to s, and n times minus sign also will be applied. So it is minus 1 whole to the power of n. Same property repeated n times. Minus 1 whole power n into d by ds of. So the property for general case, let me write, into x of t is minus 1 whole power n into d power n by ds power n of x of s. ROC does not change. So same thing for t power n into u of t. For u of t particularly, if you do, it becomes, if you substitute 1 by s and differentiate it n times, what happens is the result will become n factorial divided by s to the power of n plus 1. This will be the result for t power n into u of t. Right. Next, coming to the next one. So we are being asked to find the Laplace transform of u of t into sin t. So if you have to find the Laplace transform of u of t into sin t, or sin t into u of t. Sin t into u of t. This is what we need to find. Right. So it's a standard result. We can learn the Laplace transform of sin omega naught t into u of t. So to learn that, first of all, we need to know one property, which is frequency shifting property. Okay, I'll just take a new slide because this is becoming clumsy. Yeah. frequency shifting property. Once we learn frequency shifting property, we can understand the Laplace transform of sine and cos signals. Right. X of t has a Laplace transform of x of s e power s naught into t. This is a time domain signal e power s naught into t, or you can also write it as, it's not frequency shifting property, sorry, because this is not Fourier transform, right? But similar property. It's not frequency shifting property, but we can call it as S shifting property. We can call it as S shifting property. E power minus at into x of t. Laplace transform will be x of s plus a. ROC is real part of s. When you multiply the time domain signal with e power minus at, what happens is in the Laplace transform replace s with s plus a. In the ROC also replace s with s plus a. So ROC changes. ROC will change. And this is what is S shifting property. Using this, let us find the Laplace transform of e power j omega naught t into u of t. Laplace transform of u of t is 1 by s. Laplace transform of e power j omega naught t into u of t is 1 by s minus j omega naught. See the sign here? If it is minus a here, it should be plus a here. S is replaced with s plus a. Sign is opposite in S shifting property, whereas sign is same in time shifting property. Right. Similarly, how would e power minus j omega naught t into u of t? Laplace transform of this signal is 1 divided by s plus j omega naught. So if you add these two, what we get is, if you add these two and divide it with 2, what we get is, we get cos omega naught t into u of t. In time domain, if you add these two signals and divide with 2, we get cos omega naught t into u of t. The corresponding Laplace transform also add these two and divide with 2. Half into 1 divided by 1 s minus j omega naught plus 1 divided by s plus j omega naught. Similarly, how about sin omega naught t into u of t? We have to use linearity property here, because sin omega naught t can be expressed as e power j omega naught t minus e power minus j omega naught t into u of t divided by 2j. So we can do a linear combination of these two signals will result in sin omega naught t. So same linear combination can be done for corresponding Laplace transforms. So the first term here, Laplace transform is 1 divided by s minus j omega naught. Second term in sin omega naught t is minus e power minus j omega naught t into u of t, whose Laplace transform is 1 divided by s plus j omega naught whole divided by 2j. In time domain it is 2j, in frequency domain also same constant. So if you simplify this, it becomes once again, yeah. Okay. So we were discussing about that slide got missed. Anyway. So we were discussing about cos omega naught t into u of t and sin omega naught t into u of t. So Laplace transform is 1 by 2 into 1 divided by s minus j omega naught plus 1 divided by s plus j omega naught. Sin omega naught t into u of t Laplace transform is 1 by 2j into 1 divided by s minus j omega naught minus 1 divided by s plus j omega naught, which is equal to, so if you simplify this, the denominator becomes s square plus omega naught square. The numerator will be s by s square plus omega naught square. The next part is, so if you subtract this, what happens is s will get subtracted. It will be 2j omega naught by s square plus omega naught square. 2j gets cancelled. It becomes omega naught by s square plus omega naught square. This is the formula. Right. So coming to the problem. So in this case, the problem asked here is assign sine t into u of t. And we know the formula. Let us apply that formula. Just now we have derived it. If you have forgot it also, no problem. You can use the S shifting property to derive the formula. Express sine and cos as e power jx plus e power minus jx divided by 2 as cos. For sine, it is e power jx minus e power minus jx divided by 2j. If once you express that and apply S shifting property, you'll get the formula if at all if you forget. Now, let us apply this formula omega naught by s square plus omega naught square. Omega naught is nothing but the angular frequency of the sinusoidal signal. So it is, in place of omega naught, we are having 1. 1 divided by s square plus 1. So sin omega naught t into u of t, sin t into u of t Fourier Laplace transform is 1 by s square plus 1. Yes, correct. And Laplace transform of t into u of t, previously we have derived, it is 1 by s square. 1 by s square plus 1 and 1 by s square. So option C should be correct. And how about the ROC here? I forgot to mention the ROC for cos omega naught t and sin omega naught t. Can anyone tell me what is the ROC? ROC for this one, ROC for this part. Always ROC, this is right-sided signal. ROC will be real part of s greater than real part of the pole. The pole is j omega naught, real part of it is 0. So real part of s greater than 0. The second part, ROC, is also real part of s greater than 0. Intersection also is same thing. Intersection is also real part of s greater than 0. Similarly, for the second case also, the ROC is real part of s greater than real part of the pole, which is 0. In this case also, the pole is minus j omega naught, real part of it is 0. In the deciding the ROC, only real part of the pole will play a role. So the ROC is real part of s greater than 0. When two signals are added or subtracted, ROCs will get intersected. The intersection of ROCs will become real part of s greater than 0. So the ROC for both the signals is real part of s greater than 0. The exact same answer will be there if you take in place of u of t, if you are having minus u of minus t, in place of u of t, if you are having minus u of minus t, then also the result will be same. Let me write the result, but ROC will be reversed. Minus u of minus t. Laplace transform will be same, s by s square plus omega naught square. But since it is left-sided signal, ROC will be real part of s less than 0. Real part of s less than real part of the poles for left-sided signals. For right-sided signals, it's real part of s greater than real part of the poles. The poles here, there are two poles here, j omega naught and minus j omega naught. Similarly, how about the Laplace transform of minus sin omega naught t into u of minus t? Laplace transform is same Laplace transform as sin omega naught t into u of t. Is omega naught by sin s square plus omega naught square. ROC is real part of s less than 0. Earlier it was real part of s greater than 0. Fine. So that is the discussion of this question and the properties corresponding to it. Okay. Right. So let us discuss one more question. If I let h of t denote the impulse response of a causal system with transfer function 1 by s plus 1. 1 by s plus 1. They're saying causal system. They're saying causal system. So what is the inverse Laplace transform of 1 by s plus 1? Can you tell me? The pole here is minus 1. If the pole is minus 1, the signal will be e power minus 1 into t, which is e power minus t. So inverse Laplace transform can be e power minus t into u of t, or it can be e power minus t into minus u of minus t. The inverse Laplace transform can be any of them, because for this signal also it is 1 by s plus 1, for this signal also it is 1 by s plus 1. Because they are saying it is causal signal, which means it is a right-sided signal, so the answer is this. So the inverse Laplace transform is e power minus t into u of t, because they have given that it is a causal system. Now consider the following three statements. So since it is causal system, what is the ROC here? ROC is real part of s greater than real part of the pole. The pole is minus 1. Real part of the pole is also minus 1. So real part of the pole is minus 1. So ROC is real part of s greater than minus 1. When is the system stable? By looking at ROC, we can say the stability of the system. Whenever the ROC includes j omega axis or sigma equal to 0 line, definitely the system is stable. So if you look at this ROC is including real part S equal sigma equal to 0. Correct? Sigma greater than, this is ROC, we can also write as sigma greater than minus 1. So starting from minus 1 till infinity are the values that are part of the ROC. So sigma equal to 0 is also part of the ROC. So whenever sigma equal to 0 is part of the ROC, then signal can be said as absolutely summable. Whenever j omega axis is part of the ROC or sigma equal to 0 line is part of the ROC, then the signal that you're talking about is always absolutely integrable if it is continuous time signal. Right. So if h of t is absolutely integrable, we can say that the system corresponding to it is also a stable system. Next. So this is a correct statement, perfect statement. Next one, h of t plus 1 divided by h of t is independent of t, it seems. So h of t plus 1 divided by h of t. So we got h of t here. This is h of t. This is h of t. H of t plus 1 means replace t with t plus 1. Minus of t plus 1 into u of t plus 1 divided by h of t is e power minus t into u of t. Okay, so if you simplify this, so e power minus t gets cancelled. What remains is e power minus 1 into u of t plus 1 divided by u of t. So if you look at this one, for t greater than 0, what is happening? For t positive, for positive time, this is 1, this is also 1. So the result may be e power minus 1. Okay, right. So they are talking about only t greater than 0. For positive time, yes, this is a constant, which means it is independent of time. Correct. Independent of time means it should not be dependent on time variable. So it is independent of time. It's just a constant, right? So S2 is also correct. Next, S3. A non-causal system where the same transfer function is stable, it seems. Is it possible? A non-causal system with the same transfer function. So what is a transfer function with a non-causal system? So if for a non-causal system, if this is a transfer function non-causal system, then the impulse response will be this one. This is the impulse response with the same transfer function but non-causal system. So this non-causal, this system, does it correspond to a stable system? They're saying that the non-causal system corresponding to non-causal system with the same transfer function corresponds to a stable system. Does this correspond to a stable system? This is the impulse response corresponding to a non-causal system. But if you look at this one, it is an absolute, it is a exponentially increasing signal. So this is not absolutely integrable. This is not absolutely integrable, and hence this function, this corresponds to a unstable system. So whatever statement they are saying in the third one, that is not correct. So first, in the first statement is true, means third statement should be false, no? Because for if a causal system with the same transfer function is stable, definitely non-causal system corresponding to same transfer function will not be stable. Because, or else the other way of asking is, if it is a non-causal system, the Laplace transform will be 1 by s plus 1, 1 by s plus 1, and the ROC will be real part of s less than real part of the pole, which is real part of s less than minus 1. Real part of s less than minus 1 means we are talking about values from minus infinity to minus 1. That does not include 0. So if 0 is not part of the ROC, it corresponds to an unstable system. That way also we can say. So finally, S1 and S2 are true. So option A is correct. Okay, good. So we'll stop at this place and we'll continue in the second part. In second part, we'll focus on some other model of problems, and wherever required, I'll revise the necessary properties and concepts. Okay, and just if you can give me a minute, I'll explain a little bit about subscription. Right. So this is my profile. So I teach these subjects, signals and communications, on Unacademy platform. So there are many of my videos on YouTube. So there are many free classes that you can watch on YouTube, and there are many free classes that are available on Unacademy platform also. You can watch them too. And if at all, if you are interested to watch my complete lectures, then you should be taking subscription for Unacademy Plus platform. And if you take subscription on Unacademy platform, you're not only eligible to watch my lectures, my complete lectures, you can watch the lectures of all the other excellent teachers available on the platform. So for example, I'm just showing you some names of some teachers and their experiences that are available on the platform. So these are the teachers that are available on the platform. Apart from these teachers, there are many other excellent teachers available on the platform. So if you once you take subscription, you will be able to watch all the teachers lectures unlimited number of times. You can watch the lectures live as well as recorded also. And it's an amazing platform. So you can sit at the comfort of your home and watch the lectures, and you don't need to stay away from your home to take coaching. And I can promise you about the quality of coaching on this platform. So you can see the names here. So extraordinary teachers are available, highly efficient teachers are available on the platform for each and every subject of electronics and communications, right? And what are the other advantages that are there about the platform? So for example, whatever classes I have taken, whatever live classes I have taken in the last 8 months, all those live classes are available in recorded format. So you can watch all those recordings whenever you like it, and how many number of times you want to watch it, you can watch it. So not only my lectures, every other teacher's lectures also will be recorded, and they are all available in recorded format. So you can access any of them at any point of time, unlimited number of times. So the extra advantages over offline coaching centers is, let's say if you are not able to understand a particular class, then there will be, for the same subject, there will be multiple teachers available on the platform. All of them are really good. If you are not able to follow one teacher for a particular subject, then you can follow some other teacher also, and then you can understand the subject. So that facility is not there in offline coaching centers, right? And if at all, if you are not able to understand a particular class, live class, let's say, then you can watch the recording. Recording will be available. So if the topic is tough, then if it deserves a second watch, then definitely you can watch that on this platform, on an online platform. Whereas in offline classes, that facility is not there, right? And whatever lectures we are delivering, live lectures that we are delivering every week, whatever topics we have covered in that week, we'll be conducting exam every week. So that facility is not available on offline platform. So, and the most important part is the fees. So the fees is very affordable, and EMI facility is also available for this fees. So whatever quality we are going to give you is the best quality available in the country, and the best offline coaching centers in the country, they are charging 3 to 4 times of this fees. Here the fees is very less. For the quality that we are providing, the fees is very less, right? So, and one more thing is, you can pay this fees in installments also, EMIs also, right? And already this fees is less, and you make use of this code. This is my code, my personal code. You can note this down. If at all, if you are interested to take subscription in any future point of time, you can use this code for further discount. So the fees will be further reduced if you apply this code. Once you use this code and apply, then you'll get further discount, right? And EMI facility is available. You can avail that facility, right? And these are my contact details. If at all, if you are having any concern, and if you think that I can help you with that, you can contact me on this Telegram ID. This is my personal ID, and this is my group that I'm maintaining for resolving doubts of students on signals and communications, my expertise subjects. So if you are having doubts, you can post it in this group, and if you're having any personal queries that you want me to address, you can contact me on this Telegram ID. Okay, I'm available on Facebook as well, but preferably you can communicate with me on Telegram. Okay, so bye for now. We'll meet again in the second part.